Alright, so here we have our completed CAM part, and the next thing we should probably do is simulate the CAM project toolpath in its entirety. This will help us to verify that the calculated toolpath is exactly what we want. Now you're probably thinking, well, didn't we already perform our toolpath simulations? And the answer is yes, we quickly did, but SolidCAM offers a wide range of options that I just didn't get to touch on. So we'll get a little more in-depth regarding simulation, including the interface. Afterwards, I'll show you how we can easily generate a GCode file that can be used for machining this CAM part. This is the last part in this series of Jumpstart videos. So let's finish up. To view the toolpath simulation, let's use the SolidCAM Manager. Now, before we even open up the simulation control panel, take note that you can quickly view the wireframe toolpath from the CAM tree. Clicking the checkbox next to the operations header will display the toolpath for all operations at once. If you'd like to quickly view the toolpath for each individual operation, you can simply just click the checkbox next to that operation, like so. Let's now take a look at the simulation control panel to see the many options that we have available to us for viewing our toolpath. Now, to start the toolpath simulation for all our operations at once, or let's just say we wanted to simulate only a select number of operations, we can easily select them in the CAM tree using the Shift or Control keys. Now, for this example, however, we want to simulate all our operations. So to do that, right-click the operations header and choose Simulate. When the simulation window appears, we'll start with the Host CAD mode, which is SolidCAM's default simulation mode. First, let's click the Show Data button to display the simulation data window. This window shows us things like the X, Y, and Z position of our tools, the current feed and spin rates, and even the time it takes to machine this CAM part, all during playback. And of course, as you already know, to start the toolpath simulation, we can simply click the play button. If the simulation plays too fast or too slow for your liking, know that you can control the simulation speed with this slider. Moving it to the left will slow the simulation down, and moving it to the right will speed the simulation up. Let's run it again and move the slider to see how it affects the speed of simulation. Let's now talk about two other playback options that we have. The first option is single step mode. Each mouse click will move the tool through simulation one step at a time, and we can even watch these movements in our simulation data window. The second option I want to show you is the operation step mode. Each mouse click will play through one operation at a time in sequential order, from beginning to end. Clicking the button once will take us through only our face milling operation and stop. Clicking it again will simulate only our profile operation and stop, and so on. Now let's review some of these other buttons that we have here at the top of the Host CAD tab. If the Show Tool 2D option is selected, the tool will be represented during simulation as a wireframe circle. Now I want you to click the Show Trail and Show Tool 3D buttons. During playback, these options will also be shown in the SolidWorks graphics area. You can even perform a solid verification of the toolpath directly on the model by enabling the Solid Verification checkbox. So go ahead and click the play button once more to see what we get. So as you can see, we have some pretty powerful toolpath simulation options at your fingertips just in the Host CAD mode alone. One more thing you may want to do is change the toolpath colors, depending on your preferences. That can easily be done by clicking the Colors button. Let's leave the defaults for now and just click Cancel. The next SolidCAM simulation mode we'll use is SolidVerify. This is another popularly used mode that enables us to see the cutting tool as it moves through the solid stock material. During this machining simulation process, SolidCAM subtracts the tool movements using solid Boolean operations from a solid model of the defined stock. The remaining machined stock is a solid model that can be dynamically zoomed, moved, or rotated. It can also be compared to the target model. Now let's say that we're satisfied with our face milling and drilling operations. And now we just want to take another look at our profile and pocket operations. Well, we can simply just click those operations in the CAM tree. First, we can click the Operation Step Mode button to simulate only the profile operation. Note that the part model gets automatically updated according to the selected operations, and any operations shown up to that point are a single color. Now, let's use the Single Step Mode button to watch the tool perform the helical entry into the pocket. After that, let's click play to finish out the simulation. Let's take a look at one more button in our simulation control panel called Stop on Next. This option gives us control over where we would like our simulation to pause during playback. So, for example, let's enable the Tool Change option. Let's also highlight the operations header in the SolidCAM Manager so we are once again running through our simulation in its entirety. When we click play now, we'll see that the simulation will begin playing and then pause after the first operation. This is because our profile operation switches to Tool 2. Click play again and watch the simulation play through our second and third operations, and then pause. This is because our profile and pocket operations both use the same tool, Tool 2. Our drilling operation then uses Tool 3. Let's click play one last time to finish running through our simulation. Now that we're familiar with our toolpath simulation options, let's exit the simulation control panel and then generate G-code in preparation for machining our part. To output G-code for our entire CAM project, right-click the operations header in the SolidCAM Manager and choose the Generate command from the G-code All submenu. Our G-code is generated based on the parameters of the CNC machine controller that we chose in the CAM part definition. This G-code file opens in Notepad for us to view before it goes out to the machine. Note that the file name automatically defaults to our CAM part name, SC Simple Cover. Let's close the Notepad file. Now, what if we wanted to generate G-code for a specific operation? We can do that by simply right-clicking that operation in the CAM tree and choosing Generate from the G-code submenu. Since we only selected one operation, we are prompted to give our G-code file a name in case we want to save it. The file name automatically defaults to the operation name. Go ahead and click OK. As we can see, our generated G-code opens again in Notepad, although this time it's only for the selected operation. Now we also have the option to enter a split in our program before we output G-code, in the instance that we're working with multiple setups. For example, let's say we would like our last operation to come out as separate G-code. In the CAM tree, right-click the pocket operation and choose the After command from the Split submenu. Just use the default entry for the split name and click OK. A split is then inserted after our pocket operation. Now, when we right-click Operations, G-code All Generate, we get two separate G-code files. One file handles our first three operations, and the other file handles our last and final operation. Note that we are not limited to just one split. We can insert multiple splits in our CAM tree and generate multiple G-code files as necessary. And that concludes this entire series of Jumpstart videos, where we've performed the CAM programming of a simple cover using some of SolidCAM's 2.5D milling technologies. Thanks for watching. For more great SolidCAM Professor videos, visit the Professor page at www.solidcam.com.